So today we are going to talk about variables. Now, what is a variable? Okay, so what is a variable? So variable is nothing but, okay, so you might, if you are aware from of a C language background, so you might have come up with a topic called constant. Okay, so what is a constant is nothing but if you assign some data, it is going to be common across the script, right? So or across the program. So here also in shell script, okay, so you have variables. If you assign a value, it is going to be the same. You can access the same value with the name whatever you have assigned across the script. Okay, so in simple words, if you assign a name to a set of data, what you are assigning the name is set of data, then it is called as say variable. Okay, so what is this meaning is if you are assigning a name, so whatever the name you want, you assign your own name, so what you want to use in the script and to a set of data. Okay, so how it is going to help you? It is going to help you in lot of different ways. We'll talk about those things. Okay, so but as of now, okay, so you are assigning a name to a set of data. So this is called as a variable. And this is the syntax even. Okay, so how do you define a variable in bash shell? So in the okay, so in the first class itself I told you what is the shell we are going to talk about. So we are going to talk about bash shell, and the syntax of bash shell is name equal to data. Pretty simple, pretty straightforward, that's all. And okay, so how do you access it? Okay, so if I take an example, okay, so let's say like this. So number of oranges, a simple example I'm giving. Number of oranges is equal to 10. You're writing a small program on some fruit market. Okay, so number of apples is equal to 5. Okay, something like that you are going to write. So if you would like to access the number of oranges, you are going to access this one, then what you are going to get ultimately, you are going to get this value. Okay, so with respect to data, okay, so what is the data you can put? You can put characters, or I can put it as like this. Your data can be single character, means, okay, single character means, okay, so it can be A to Z or capital A to Z or 0 to 9. Okay, 0 to 9. So even numbers also. Okay, and underscore, that's all. Okay, you cannot put any special characters in these particular variable. Okay, variable okay, data. If you have variable, okay, so if you have special characters in variable data, so what you need to do is, or let me, it's not like this, let me put like this. So single character, okay, your data can be single character, your data can be single word, means multiple characters, it can be single line, and even it can be multiple lines. So what is this meaning is, it doesn't have any limitation, your data. So you are putting two characters here, so 1 and 0, or okay, so you can put a word, you can put a line, or you can put a multiple lines also. So your variable doesn't restrict you as you are increasing the number of lines in that particular variable also. So ultimately what you are getting no data types. Okay, you don't need to define what type of variable is. So if you are aware of any programming languages like C language, you are defining a variable, you need to define what type of variable it is, whether it is an integer, whether it is a floating value, whether it is a character, okay, or whether it is a long character. So you need to mention a lot of things, right? So here you no need to worry about those things. So it's simple string, that's all. There are no data types. Okay, so input is considered as string. So these are very basic, you need to understand. Okay, so input is considered as string. String is a combination of words and characters. Okay, it is a simple string, and in this particular string, if you have any special characters, you already know how to restrict special characters, either you go with single quotes or double quotes. So you provide the input. Okay, so example, if you take, okay, so my line, some variable is equal to, so let's say, so today is a good day. So what is the special character I have here? Space is a special character here, right? Space also falls under special characters only. It does not belongs small a to z, okay, or capital A to z or 0 to 9 and underscore. Okay, so this is also, space is also considered as special characters. So we already talked about quotes class. Okay, if you have any special characters, restrict that with single quotes or double quotes. Okay, so you know the difference. What is the difference between single quotes and double quotes? Okay, so let's say if you want to put some also special characters like, okay, so a is equal to 10 star. So star is a special character, so what you need to do, you need to restrict with quotes. That's all. Okay, so what you need to understand here is the data whatever you are providing, there are no data types. There are no data types. Everything is a string, and there is no data limitation also. And there is no data limitation. Means you already talked about it, can be a single character, single word, single line, or multiple lines. Doesn't restrict you. Okay, now how do we define the variable? Simply already we talked about name is equal to data. Now you need to access it, right? So in order to access a variable in shell, so what you need to do is you need to give a dollar preceding to your variable name. Preceding to your variable name, you need to give a dollar character. That's all, pretty simple. And if you can give this particular variable to any command. Okay, so if I would like to see the data, so then what is going to happen? It is I have to use echo command. So echo command is to print. Now what is it is printing is, it is printing the data in the variable. It is printing the data in the variable. Now, so you need to understand another basics also. What is happening whenever you define a variable? So let's say you are defining, okay, so name is equal to, let's say I'm giving Raghu. Okay, so I'm just giving name is equal to Raghu. So what I'm getting here, okay, so I'm defining a variable, it has to store somewhere, right? Defining a variable, it has to store somewhere, then only you can access it, obviously, right? So if you see here an example, okay, so name is equal to Raghu, and if I give echo dollar name, what you are getting, okay, you are getting the data. So how you are getting the data? Unless and until it's stored somewhere, how do you get the data? You'll not get the data, right? So it is storing somewhere. Where it is storing? So it is going to store in a component called as memory. Going to store in a component called as memory. So whenever you define a variable, so your shell takes that particular one and puts in a memory. So in memory, it is going to reserve a chunk of memory, and in that particular chunk of memory, it is named that particular variable as name, okay, and it puts the data, whatever it is. Okay, now you need to understand, okay, so while accessing, right, so while accessing, again you need to search in the memory. Again you need to search in the memory. So in order to search in the memory, okay, so you have to start from starting, okay, and you have to end at the ending. So you don't know where the memory is. It's a pretty difficult task, right? So I have, let's say, 256 GB of RAM, very big server. Okay, so 256 GB of RAM on an operating system. I'm trying to define a variable. I don't know where this particular memory is stored. I have to search all the way from starting to ending where my variable is. So finally I found here, and I just returns the value. So this is a time consuming process, right? Obviously this is a very much time consuming process. So that's the reason, okay, so usually, okay, whenever you define a variable, it will not go randomly into the memory, whereas it is going to store into the process ID. What is this process ID? Okay, every command you execute in Linux and Unix operating system will get a process ID, right? So the shell, whatever you launched over here, you got a process ID. What is the process ID? If you simply give ps enter, it shows you bash is having certain process ID. Okay, and you have to go to the okay, little basics of Linux. Whenever any process ID creates, what happens? Whenever any process ID creates, what happens? Certain amount of CPU, certain amount of memory is allocated for each and every process. Okay, this is pretty basic thing. Okay, so whenever a process ID creates, okay, so a certain amount of memory is allocated for that particular process ID. So assume this is the memory allocated for that particular process ID. Now you go and define a variable. So in this particular memory, it is going to reserve certain amount of memory, and okay, it actually define that particular variable here, which makes sense, right? See, if you're everything you're scattering, okay, so while collecting the data it is very difficult. So that's the reason. Okay, so of course, okay, so I mean, if you're scattering means other process IDs having other information, so you don't have any security point of thing. Okay, so one process ID should not be in a position to look into the other process ID. Otherwise there is a security issue. You log into the shell, you got a process ID, I log into a shell, I got the process ID, we both are two different users. If I'm able to look into your memory area, okay, I'm able to see the data which your memory is holding, so which may contain a valuable, okay, sensitive data, so which should not be allowed. Okay, Linux is a very security operating system we talk about. So how is this is one of the way. Okay, so it's also can be, okay, so this is one of the things. So one process ID will not be in a position to look into other process ID. Okay, so they are completely into a different containers, differently isolated. One cannot look into another unless there is a relation. The relation we'll talk about later. Okay, so one cannot look into another. So you define the variable, it is going into its process ID. What are the memory allocated to that particular process ID? It is storing there. Pretty fine. Now, okay, so what you are trying to do, you're trying echo dollar name. So then what immediately it is happening? So your understanding, okay, might be a little, I'm not sure how did you understood, but okay, by looking what you will understand is usually, so echo command is actually going and fetching the value, okay, and printing the value on the screen. That is what your understanding meant. Our usual everyone's understanding is that one. Okay, but no, that's a pretty wrong way. Why? Because just now I told you, right? So every command you create, it gets a process ID, but defining a variable is not a type of command. It's an inbuilt of shell. You don't need to worry. But echo is a command. Echo command also should get a process ID. So when it gets a process ID, it goes and creates a different process ID and different memory in the memory. Okay, so different isolated memory is allocated to echo command, but how echo command is able to access the variable? So the variable is here and you are trying to access it here, which is not available. So you will not get it obviously. But how you are able to get it? If you see this example, okay, so how you are able to get it? You are getting the data, sorry, right? How you are able to get the data? So echo command is a different process ID, and your okay variable is the other process ID is variable. So how do you get it? You'll not get it, right? So the way of echo command, whatever our understanding is wrong then. Okay, so as we are getting the data, so let me tell you how it is going to happen. Now what you are doing, echo dollar name, that is fine. So what you next immediately you are doing, you are entering, okay, you are hitting enter, right? So whenever you hit enter, who has to run this particular command? So your shell has to run this particular command. Your shell is taking care of running, right? Now while shell is running, shell observes actually, so completely. If there are any special characters, yes, dollar is a special character. Now shell knows, okay, so yeah, this is a variable. So then immediately it looks into its value. Till now still echo command is not getting executed. If echo command started executing, it creates a process ID. Still echo command is not, still shell doesn't enter till echo command. The first immediate thing it looked is there are special variables. The special variables is dollar character. Dollar character is a variable. Okay, so then immediately looks into the memory because it is being executed by shell. It knows, it goes there and looks for that particular variable and fetches the data, and it got replaced. Okay, so how it got replaced? It got substituted as echo space Raghu. So then echo command starts executing. So as echo command starts executing, okay, so now what echo command does, whatever the input is given, it prints on the output screen. Now you are getting Raghu. So these are the different layers happens whenever you execute a command. So the other day in echo command, okay, so in codes we talked about star, right? So they're also the same thing. So your echo command is not actually taking the input. If it is actually taking the input, it can take star and it can print, but echo is not taking. Your shell is actually looking if there are any special characters. Yes, there are special characters, and that particular specialty will be enabled by your shell. And finally the input whatever you got over here, so it gives to the echo command, and echo command will take that particular input and finally prints. Got some clarity, right? What's happening? Okay. Okay, now, so you know how to define a variable and how to access a variable now. Okay, so let's talk about, okay, so how do you unset a variable, okay, or undefine a variable. So you have a command called as unset, and you give variable name that is going to, okay, so unset the data whatever you have given. Okay, so here I have used only NAM. I'll give unset. So means the variable data whatever you have defined, okay, so will be given to the free memory, okay, of that particular process. So the data is going to get wiped out. So strictly talking, okay, the data doesn't get wiped out. The data never gets wiped out actually, unless it is overwritten. Unless it is overwritten. So do you ever know how rm command works? rm-f, you file name if you give. So what your assumption? Does it actually remove the file? Any idea? Available is 8 GB. So let me create a file. See, dd is a file. Okay, dd is a command where you can create a file of certain size whatever you want. So I want to create if is equal to /dev/0. Okay, off is equal to dd file. I'm just giving dd file. Okay, so bs is equal to 1 MB, count is equal to 500, means 500 MB, 5000, 5 GB. So let's see how much time it is taking. I'm trying to create a 5 GB file. See, at least it is taking 20 seconds, 30 seconds. Let's see how much time it takes. Or else for you to get clarity, I'll do one thing. Uh, time is time, and I'll run this command. Let me put as 3 GB. It's taking too much time. So let it create. I'll be back in a moment. Oh, it's done. Okay, that's fine. So now if you see actually, so how much seconds it has taken? 45 seconds it has taken. 45 seconds it has taken. So let me remove this file. So if you see ls-lh of this particular file, so you can see this file has 3 GB. So it to create it took 45 seconds. Obviously for removing also it should take the same time. True, that's true actually. So how much time it has taken? It has not taken not even a single second. Just you hit enter, it came out, right? So what happened? Does rm command is actually wiping out the data? Okay, taking duster and removing the complete board? No. Okay, so what is happening? Okay, so it never deletes the data. So if you give touch on any file, okay, so if you are aware of okay, so if you are aware of unlink command, so what unlink command does, it will remove a soft link or a hard link. Okay, so if I try to give unlink on a normal file, what happens? You give ls-l on this file, what happened? The file is removed. Okay, so what unlink is doing? So file system will have a inodes. File system will have a inode table. I'm not sure whether you are aware of these basics. The Linux operating system, your inodes, okay, your file system will have inode table. Okay, so inode table is okay is divided into certain parts where you'll have used and unused. So till now your dd file, okay, so we'll have an inode, okay, which is in used section. What your rm command does is, what all the files and directories whatever you have in that, okay, inode, what are the list of inodes, it takes that particular list and sends to the unused inodes. That's all. If inode is moving from, okay, so used to unused, and the all the blocks which are associated with that particular inode will be considered as free only. So the next time if the inode is moving to used thing, now on the actual file system, so as the inode is moved here, it start overwriting the data on the actual data. Okay, so that's the reason even if you remove the content also, so you'll see a boards of people saying that, okay, okay, we can recover the data, we will recover the data, right? So that is what usually happens. Now here, okay, so we're talking about unset command. See, unset command dollar, if you are giving simply variable name, I don't think so it is actually, okay, going to wipe out the data. It will simply make that particular variable, okay, available to the next time usage. That's all. Pretty straightforward. So unset is to unset the data whatever you have set. That's all. Okay, now whenever you go with, okay, so whenever you go with any scripting and you are using a variable, you don't need to unset the data whatever you have set in your scripting. Why? Because, okay, so whenever you start executing a script, it gets a process ID. Obviously it gets a process ID. So what is the basic syntax of your Linux and Unix operating system? Might be this syntax I have told in echo command. The syntax of your echo command, any command is, okay, so you'll be having command name, and it may have options, and it may have inputs. Okay, so you may have options or you may not have inputs. Those are not mandatory, but command name is mandatory, right? Now how do you execute a script? So you execute the script as /script. So the first one whatever you are executing is a command. Okay, so the script whatever you are executing is a command. You know that is a shell script, and that is how it is going to execute in the back end. But on the top layer you see, okay, that is a command. That is a command, and it gets a process ID. It gets a process ID, and what all the variables you define, it goes into that particular process ID, and once script completes, automatically the process ID get closed, all the variables you define automatically gets wiped out. Okay, whenever the process ID closed, what happens? This particular yeah. So whenever a process ID closed, whatever the data you have, okay, so allocated for that particular one will get completely erased. So I'm just using eraser. Otherwise, it can. Okay. So all the variables defined in that particular area of memory, which is reserved for that particular process ID, will automatically freed by your kernel. Okay. Process ID gets creates closed. So who will take care is everything will be taken care by your kernel. Okay. So everything get wiped out. So you no need to worry. So that's the reason. So we usually will not see a command called as unset in our scripts. Unset in our scripts. Okay. So let me write a small example just for your understanding of variables. So data sh. So slash bin hash bash. So let's say I am using a variable R. R is a variable. What is the color of variable? Slash E 31M. So you remember the colors in echo command. I'm just trying to use define those things in a variable. So let's say I want to use blue. Blue is equal to slash E 34M. And so let's say yellow on red. Yellow on red. So I just use slash E. So what is yellow color? 33 colon red is 41M. Or red on yellow is better. Let's see. Okay, that's fine. Now I'll just give echo. So how do we print something? So echo hyphen E. Now I'll go with double quotes. So if I would like to print red color, so what I'll use $R means this value get replaced here. That's all. So which makes your job easy. So $R and then printing red color. Now after that, you know that, okay, so every time you need to reset the color. So I'll neutralize the color by using N. N is equal to slash E 0M, that's all. So immediately after red color, so what I'll do $N. So which makes your syntax very clear. So previously if you actually replace this particular one without variables, what is going to happen? So this is how it will be. So slash E 31M slash E 0M. So which is little confusing, right? So instead this is the better way. And if you want to change the red color automatically, R variable, so R stands for red anyhow, you want to change the color, you change here at one location, so it is going to change across the scripts wherever you have that particular value. So instead of changing on each and every line, okay, so variables make sense, right? It helps you in replacing the data, generic values. If you are using a single data across the script, so instead of using the data directly, so the data can be a word or whatever it is, doesn't matter. Okay, so instead of changing on the complete script, you define a variable and you use the variable across the script. Whenever you want to change, you just change the particular variable and you're done. Okay, so now red color, and after that echo hyphen E. Okay, so $B blue color N and echo hyphen E $YOR yellow on red color $N. Okay, so let's try to print or execute this particular script. So can you see red color, blue color and yellow on red? So this is how, so usually you will get it. Okay, now So let's say, okay, you want to add a user add script. Okay, so user add .sh. So if you want to add a user, so what are the things you require? You require a username, that's all. Slash bin slash bash. So let's say username is equal to, okay, so Ramu. Okay, so then immediately what I need to do is username. Okay, so user add dollar username. Not, I am not going to use Ramu. Okay, so user add username, and after that if you would like to set a password, so how can you set a password? You have a different ways. You want to get a random password, right? So what we usually use is date command. So from date command, if you pass that particular one to md5 sum, okay, you always get a different value. You always get a different value. Why? Because you are going to execute in every time you execute a date command, you'll get at least a second change in the date command. You get a different value. So vim, okay, user add.sh. I'm going to use this one. Yeah, I want to get 6 characters. How do you get it? So cut command we already talked about. Cut hyphen c 1 to 6. Oh, oops. Okay, sorry. So date command and pipe cut hyphen c 1 to 6. So you are getting how many characters? You are getting 6 characters. So next time you execute, you get 6 characters. Next time you execute, you get different 6 characters. Okay. So now let's go and you give this particular one in user add. So user add dollar username. Now after that I need password. So how can you set a password to a user? Okay, so you can set the password to the user by using, okay, so echo. So what is the command we are using? So I want to use date pipe md5 sum pipe. Okay, so cut hyphen c 1 to 6, right? So this is the command. So this command, whatever we're executing here, will get a 6-digit value, 6 characters. So echo those 6 characters. Now immediately you need to send that particular one to password command. So password command has certain options. I'm not sure whether you have tried. So password command has certain options. So here you have an option called as stdin. Okay, so but it is only for root user. Okay, so new read tokens from standard input means, so whenever you execute a password command as a root user, you'll get, okay, you will not ask for, it will not ask for present password. It always asks for new password and retype new password whenever you execute as a root. Okay, so now password hyphen hyphen std in, what is the username? Dollar username. So then what it does is, whatever the password it is coming from here, will set the password to this particular user. Now password is set. So let's say after setting the password, okay, so whether I need to, okay, give the password to the user. Okay, for that what I can do, echo dollar, okay, so user created. I'll just create some message, echo, okay, so user name slash password equal to, so what is the username, okay, and the password is, we don't know the password, right? So here comes the little difficulty. Okay, so what you need to do is, here you need to, okay, let me use this one, but it is not going to be the exact way actually, but just for demo purpose I'm giving, but this is wrong, completely wrong. Okay, you need to use a different way. You need to use a variable in that case. That particular thing we didn't talk about till. So date, okay, so might be this is the best example which I can come again. Okay, now I have printed the username and password on the screen so that I will copy the content, I will give it to the user. I want to go a little more beyond. I want to change the password of the user. So I want to ask to, I mean, I want ask to ask the user to change the password forcefully whenever he logs in for the first time. So for that, what you do, CHAGE, okay, -D 0 and the username. So here I have not used anything other than which an administrator use. As a user, as an administrator, you need to know user add command. As an administrator, you should know password command. As an administrator, you should use change command. But what my scripting is helping you in such a way that to defining the variables here. That's all. In defining the variables. Okay, and you're accessing those variables. Now this is the simple script. Okay, so even you can just copy. I mean, as a normal user, I cannot, okay, I cannot add a user, but I'm putting this particular script for you. You can just copy and put it on your desktops or I mean virtual machine, wherever you are using, and try to create a user. It will create a user now. Okay, now let's say I want to create another user now. So immediately what I'll do is I'll modify this particular script so in such a way that, so I'll just use Raju. That's all. You don't need to modify everywhere. So if you have used Raju everywhere on the every line, that is also called as script without variables. If you put these commands, that is also called as variable. That is also called as shell script. But what is the difference? See, if you come to the shell script, so you follow certain things like variables. Okay, so you are using these particular variables, and you change this in this location. Automatically, it is going to change in all these locations automatically. You don't need to manually put efforts to change in each and every line. So variables is going to save you a lot of time. When you feel this particular variable or this particular data may change in the future, so you always go and define that particular value in a variable. Okay, now and also one more point, after coming out of while coming out of script, I'm not using unset command because the variable which was defined in this particular script will get automatically cleared as the process ID is going to get cleared automatically, so you don't need to worry. Okay, so that is about, okay, a simple variables. Now there are certain properties of the variable. The next one is properties of a variable. What is this properties of a variable? Whenever a variable creates, it gets certain properties which we need to discuss. Okay, so what are the properties is, the first property is it is read write. What is this read write? Let's see an example and then we'll talk about. I'm defining name is equal to Raghu. Sorry. Okay, that's fine. Okay, now I'm giving echo $name, so I'm getting the value. So now immediately I see in, okay, this spelling is wrong, I'll just go and give RAGHU. So what is happening? Simply overwritten. It's simply overwritten. It didn't throw you any warning or an error saying, hey boss, this variable is already defined and it is already having some data. It's not shown you anything, it's simply overwritten. So that particular property is called as read write, means the variable has a overwritable property, writable property. Okay, so right, so let's say I'll take an out file. So if I give rm out, it's removing. So let's say if the file, see, if you see ls-l of out file, as you have writable permission on this particular file, it's not giving any warning while removing. So let's say, okay, so if you give chmod 400 of out file, now if you give rm out, see, now this file is write protected. Do you want to remove this particular file? It is asking, right? So if you don't have writable property, only you'll get a warning, even in the case of file and even in the case of variable. So your variables you are able to read, because echo $name you are giving, you are getting the value, means you are going to shell and getting the value, you are able to read that, as well as you can even overwrite it. That has a read write property by default. Now what you can do over here is you can make it as read only. You can mark it as read only. So okay, that's fine, but how it is going to use you whenever you set it as read only? Let's see. Okay, so name is equal to Raghu, and if I set that particular variable as a read only variable now, so how do I set? By using read only command. So where is this? Yeah, so how do you set it is read only and your variable name. Okay, so that's what I'm doing here. And what is my variable name? Name. And if you give, okay, so echo $name, so you're able to access it because you're okay still having read property. But if you try to override the content, let's say I just want to make it as Ramu, so what you're getting read only variable. You're getting it as read only variable. So once you set a variable as read only variable, you cannot set it back as read write. You cannot set it back as read write. So where this particular read only variable can help you, so assume you have a script, okay, so very big script you are writing, okay, so you define a variable at one point of time, you may use the same variable name in some other point of time. So you are defining a variable in, let's say, in first 10 lines one variable, or first 100 lines you are one variable. So your script is going beyond 1000 lines, and after the 1000 lines you may forget that you already defined the variable, and you use the same variable, it will overwrite over there. So it should not be done. Assume I'm putting a scenario, that's all. Okay, so in that cases, if you feel a variable is very important and should be same across the script, so you simply mark that particular variable as read only, and it will be same all the time. So now system uses this particular variables widely. This particular uses this particular variables widely. So let's say rm-f out file. Okay, so I'm creating a file touch out file. So I'm giving ls-l out. So what is happening? It is creating a file. It is creating an empty file. Touch creates a empty file. Now, so this particular file is automatically getting some permissions. So how I am getting those particular permissions? You are having an umask value. So umask value is set it as 022, and hence you are able to, 1 second. So you are setting a umask value, and hence you are able to, okay, get those permissions. That's fine. That is pretty okay. That's clear for me. Now you take this one. So how this touch command came to know whether the file should be created with SB48 user or users? Because I logged in with, okay, so I logged into this particular machine with EC2 user. From there I did sudo su hyphen. From there I have done SB48. Okay, and here I am using touch command. So here what is happening? The touch command is using this particular username. Clear? Username. how touch command came to know, okay, this particular user is SB48 and the group owner is users? There has to be something, right? Now, so system uses variables widely. System uses variables widely. So here you have, every user will have a user ID. So if you give ID enter, so name is for our purpose to understand usually. But here you have an user ID. So here if you go echo dollar and if you give UID, so what is happening? You are getting a value 1012, same value. So this particular user is having 1012 user ID and that is set in a variable now. So the touch command inside, okay, whenever it is touching a file or creating a file, it looks what is the UID variable and takes that particular value and it applies that particular permissions, right? Now what happens, so touch command is looking for this particular UID. So if I make that particular UID is equal to 0, if I make that particular UID is equal to 0, so then the file whatever it is getting created will get as a root user, will get as a root user. So what is happening, ultimately you are becoming a root user. See, password command you give, so password command if you enter, so firstly it is asking for current Unix password, but you go to root user and you execute the same password command. Okay, so what it is asking for, it is asking for new password. It's not asking for the current Unix password. So there you are using the same password command, here also you are using the same password command. But how do you came to know that, okay, how password command came to know that, okay, it is a normal user or it is a regular user? See, this particular password command also looks for the variable UID. So here the UID is equal to 0. But whenever you log into SB48, okay, so here the UID is 1012. So based on these particular values only, okay, so your command works. So here, okay, so the UID variable is a read-only variable. So and hence it is a read-only variable. You cannot override the data. Your system is secure here. If that particular variable is not a read-only variable, that is a big-time vulnerability in the system. I can become root user whenever I want, even I log in as a normal user without entering a sudo commands or even without entering a root password. I'll become a root user. I'll not, okay, treat an operating system as a secure, okay, unless and until you have certain things. So this is also one more thing which makes your system security. It also comes under one of the security parts. So read-only variables, you may not use it properly or regularly, I can say, but system uses these particular variables very widely. And okay, so once you set a variable as a read-only variable, even as a root user, you cannot make it, okay, you cannot write it or convert it back to read-write. You're set, you're done. Okay, so that is the limitation you have. Now, okay, I hope I'm clear with this particular property. And the next one you have is local. What is this local? So let's see an example and then we'll talk about this particular local property. Let me write a small script or echo dollar name. Yeah, one more point here. So what, okay, so that's fine. Okay, what happens, okay, I mean, if I want to use the variable back again, so you should get it out. Okay, you set a variable, you that is marked as read only, you cannot use that particular variable because it cannot be overwritten. So if I would like to use it again, what you need to do is you need to close the terminal, come out of the terminal, all the data in the process ID will get wiped out automatically along with the read only variables whatever are set. Okay, so you don't need to worry. So only thing you need to do is you need to come out. One second, guys. Now, and yes, so coming to the local property, so let me create a script. So I'm defining a variable name is equal to Raghu, and if I give echo dollar name, I'm able to get the data. This is pretty fine. We are already talked about this. Now we'll do one thing. Okay, I'll create a script. And I'm giving echo dollar name. See, whatever the variable I have defined in the same terminal, okay, I'm using the same variable. I'm trying to access through a script, that's all. The variable is already defined in the same terminal. And you are just trying to access that particular variable in a script, that's all. Now try to use script 5.sh. Are you getting the data? No, it's empty. You're getting trying to access here, you're getting the data. Can any one of you tell me, okay, what is happening? Why you didn't able to get the data? Any one of you?
ID was closed.
Sorry?
Echo dollar, echo dollar name.
Mm-hmm.
Process ID was closed.
Echo dollar name, the process ID was closed. Uh, Process ID was closed in the sense? I think that may not be correct, Ramchandra. Little correct. Just think. I already discussed about this point. Okay, why you are unable to get it? Just need to think, that's all. Okay, let me tell you. So here, okay, so yeah, where am I? So in this particular diagram, so what I have shown, so whenever you define a variable, okay, so it goes to this particular process ID. So now, okay, I just told you the syntax here, right? So where is the syntax? Yeah, here itself. So whenever you define a command, okay, so whenever you execute a script, it gets a new process ID. You get a new process ID. So whenever a new process ID is getting created, so it creates a new process ID. The variable is here. You define here. That's pretty fine. Okay. but whenever you execute a command, okay, your script, it creates a new process ID, and you're giving echo dollar name, it is going to try to access it here. The variable does not exist here, it exists here, and hence you are unable to get the data. Okay, so that is what happening behind the scenes. Now you can get it, okay, so you can get the data even into that particular script also. So how do you get it? Okay, so as just now, okay, in the starting of the variables I just told you, it is not possible, okay, to get a data of one process ID to another process ID. Yes, you'll not get it unless, okay, if those doesn't have, okay, unless if they have any relation. Here they have a relation. What is the relation they have? Are you aware or not? Every process ID will get a parent process ID. Okay, so child process ID, okay, is the process ID we're talking about. To get a child process ID, what you are going to have? You are going to have a parent process ID. So every process ID will get a parent process ID. So PS is going to show you the child process ID, okay, or the process ID, but this process ID will have a parent process ID. So if you would like to see what is the parent process ID, so you can see here 23070 is the parent process ID of this particular process ID. So if you give P tree, not sure, PS tree, I think. Okay, so if you give PS tree, and I think you can give the numbers -P. So where is our process ID? 23071. So where is 23071? 23070 is there. I think it just cut here. So yeah. So here it has to be. So this is the 23071. So this has 23070. This has a parent process ID. This is the one. This has a parent process ID. This is the one. This also has a parent process ID. This also has. This also has. Finally, it started here. This also has a parent process ID. This is the one. Okay. So ultimately, the main process is called as, first process is process number 1. Under process 1 only every process ID will be created. So this is how you have relation. So every process ID, okay, so but if you see this process ID and this process ID are different because those two parents are different. So you take here, this process ID is different, this process ID is different. Okay, so both has a two different process IDs, but parent is same, right? So here also, okay, you take this particular process ID, okay, you take this particular process ID, so you have a parent. Okay, now there is a certain thing happens, there is certain what we say, certain background phenomenon happens whenever a process ID gets created. Okay, so what are the things which happens is, one of the thing is, whatever the environment area you have in this particular process will be given to the child. Whatever the environment area set to that particular process will be given to the child completely. Okay, so what is happening here is, whenever you define a variable, so assume this as the process ID. So assume this as the total process ID. Okay, so now whenever you define a variable, okay, so your complete okay, a process ID memory is not allocated only for variables. Okay, there is only very small section which is allocated for variables. So this is for variables and functions also, the same area it is going to use. Okay, now whenever you define a variable, again this particular area is also divided into two parts. So this is divided into two parts. So what is these two parts are called as? One part is called as L, whereas another part is called as E. I'm just giving, okay. So L stands for, there I cannot write, L stands for local and E stands for environment. Okay, this is the environment we are talking about. Okay, so whenever a process ID gets created, okay, so you will get a small area for variables, and that particular variable area is divided into two parts. One is local and the other one is environment. So this complete environment is actually given by your parent process ID. This area is completely got it from a parent process ID. So this will have a parent process ID, right? So parent process ID has a certain environment, it directly dumps that particular one into environment. Okay, now what is this local? This local is what you define a variable. So you define name is equal to Raghu, it comes to local area. So it is available here now. Now what you are doing, you are trying to create a script. Script is getting a process ID, but who is executing this particular script? So who is executing is this process ID is actually executing the script. So this becomes now parent process ID to this particular process ID. Yet it is a child to another process ID. It has a child. Okay, it also became a parent process ID now. So this particular area or environment area now, okay, will be dumped into this particular process ID. Okay, will be dumped here. Now, okay, this is the overall idea. Now you come here, you define a variable, it is defining in local, whereas if you try to put that particular variable in environment, so this environment area will goes to the child, and child also can access the variable. So see, so how can I put that particular variable in environment variable is I'm using export. I know you might be using this particular export command from, okay, so pretty long time if you are a long time user of Linux. So export variable of what is the variable name I define? And NAME. Okay, sorry, export, no, export name. Okay, now you try to execute script5.sh, you're able to get the data. What you're exporting, you know the export word, right? So if you ship something from one location to another location, you call it as export. So what you're exporting the local variable from this area to environment area, that area to environment area. So now the variable is available in environment location, not in local. Okay, so now this particular, okay, so variable is kept into the new process got created. So that is the script whatever you executed. So the script got a new process ID, so it is there in the environment. So that particular variable is also pushed into the script file environment, and it is able to access. While accessing, it looks in both the areas. While accessing, it looks in both the areas, but while defining, it goes to the local area by default. Even you can put it into the environment direct by using directly the export command, and hence you are able to access it. That's all. So this is the scene happening behind the export command. So you can make it as environment variable by using export command and the variable name. So you can directly define the environment variable by using export name is equal to data. So here also the same thing. Okay, now if let's see in a different way, okay, let's see in the reverse way. So if you would like to define something on the child process ID and you want to import now, so you know export now. Now let's see how the import happens if you would like to do the import. Okay, so what I'll do is export name is equal to name1 is equal to Ram. Just defining this. script6.sh. So now if I give script6.sh and if I give echo $name1, okay, you'll not get it obviously. Why? Because the variable is defined in this particular script, and once it is defined, you came out automatically, the process is closed and you don't have the data. Okay, so you came out, you cannot access it. Why? Because this is a different process ID again altogether. Now, okay, so even though you exported, so you cannot access it. Why? Because if this particular child process ID becomes a parent process ID and its childs only can access the variable, but not its parent. So export command relation always happens from parent to child, not from child to parent. Okay, so now if you would like to get it from, okay, so child to parent, so what you need to do? Okay, so you need to do a simple thing. So you need to execute a script with a different command. You need to execute a script with different command. So how do you execute? I'm going to use a dot command. I'm going to use a dot command and the script 6.sh, and if I give echo $name $name1, you're able to get the data. So what happened? So used dot command. So dot is a command. Dot is not a present working directory there. Dot doesn't denotes a hidden file. Dot is a command. Dot space. So here you see the first one, whatever you have is a command. So the first one you are using as a command, and the input you are giving is a script name. Input you are giving is a script name. Okay, so dot is a command. Now how you are able to get it? Okay, I can understand that you can say that I can understand dot is a command, but how you are getting it? Okay, so dot is a shell built-in command. Dot is not a regular command. Dot is a shell built-in command, means the shell built-in commands will not have any process IDs because that command already came with shell, and shell itself will handle those commands. It will not get any new process ID. If you give enable command, it will show you what are all the shell built-in commands. So you have dot as a shell built-in command. So you might be using cd command. Cd command is a shell built-in command. Cd command also doesn't require any shell built-ins. Okay, sorry, doesn't create any process IDs. The other command we talked about, exit command, export command, any other command, read only command, unset. Okay, so all these commands are history command also. Your history command you usually use, right? So where is that history? Yeah, history command is also a shell built-in. Most of the commands are here, you see, okay, you use regularly are shell built-in commands. So these commands will not get a new process ID because these commands already came up with a shell, and shell handle these things. So no process ID. Yeah, so no process ID now. But what you are trying to do, you are executing a script. You're executing a script. So now there is no process ID. Okay, I can say like this. Instead of saying no process ID, okay, so it uses the same memory. Okay, so these particular commands will use the same memory of your original process ID. As it doesn't have a new process ID, it will not get a new memory also. But the command has to execute. So the command it is getting executed as, okay, so and in that particular script, what you are having, you are defining a variable. So you define a variable, it goes to the local of this particular process ID only. It will not create any process ID, right? So whatever you have, it puts into the same process. So you define the variable, it went to here, and you close the script. Still the variable is available here. Why? Because the process is still alive, and hence you are able to get the data. Okay, so system uses this particular dot importing the scripts, okay, widely. So you take dot bash underscore profile. So you take how this particular dot bash rc file is getting executed. It is importing dot space dot bash rc use. It is also importing another file, etc bash rc with dot. So this script is getting executed. Along with that, if there are any variables and functions, it actually imports. That's all. Okay, so this is how, okay, so usually the export and import happens with respect to variables. And the next one you have, okay, so the next property you have is scalar. So I'll stop here. Okay, from the scalar property, we'll talk in the next class. The next class is going to be on Tuesday, not on Monday. So we'll meet on Tuesday 9 p.m. If you have any questions, you can ask.